All right, everyone. Good morning. I hope this is, yes, this is recording. Okay, I had a great question from, I hope you don't mind, Chloe, but I'm going to call you out. So I had a great question from Chloe this morning, and she was asking about the lab report and if we would go through it in class. So I'm going to do that, and I'm going to go through it with you right now. So again, this is your, I'll back up the truck just a little bit. So you go into Microsoft Teams, you open up your particular class time. This is 8th grade, Tuesday, Friday, 12 p.m. So I would open that up. On the left-hand side, it says class notebook. So you're going to click that. Then you're going to go to your three little books right here. You're going to find your name. I'm going to use Miss Bannister as an example. You go into class notes. So class notes is where that I put most of the work, just because I don't want to mess with quizzes, handouts, and homework. I don't want you to get confused. So I try to concentrate on class notes. I'm putting everything there. Drop the ball lab. So right here it is. And for a couple of you, I named it drop and bounce lab. It's fine, either one. So then you go over to your questions. The first thing we have here is, what was the purpose of the experiment? The purpose is to see how different materials impact the bounce of the spheres. So that would be your first answer. Your second question, what were the independent, dependent, and control variables in the investigation? Just a second, let me ask my husband. Hey, Adam, could you pause that video? I forgot to. Okay, thanks, guys. So the independent variable is going to be the thing that the scientist changes. So the variable that the scientist changes, one thing. It can only be one thing. So that's going to be the material. The dependent variable is the thing that the scientist steps back and says, oh, I wonder, I'm curious to see what happens. So the dependent variable is going to be the height of the bounce, and then the control variable is going to be the thing that doesn't change each time that you run the experiment. So that's going to be the ruler. So for example, that ruler should never move. The units of measurement should never change, so it should always be centimeters. Write a hypothesis based on the observation. So that's you guys. I'm going to give you, that could be anything like, if the material affects the bounce, then the bounce height will change. So I'm just going to put that in right here. It should be anything, any sentence, okay, Miss Yui, with if and then. So you can rewind this and listen to my example in a minute when you watch this on your own. So I'm going to keep cruising. Experimental methods, what tools did you use to collect the data? So that's going to be something like your, the ruler, the simulation. So the simulation, the ruler, anything else that you used in the simulation. Describe the procedure that you followed to conduct the experiment. So basically what you did is you lined up the spheres, you bounced them, you observed how high they went next to the ruler. So something like that would work. Describe the procedure that you followed. Oh, so that's this one right here. I'm going to go X. Describe the procedure. That one would go right there. All right. Data and observations. So let me make sure I didn't miss one. Record your observations. So here you just tell me what you saw. What did you observe when you dropped those different spheres that were made of different materials? Conclusion, what conclusion can you draw about the relationship between the temperature of the ball and its heights? Is there a direct and inverse relationship? So right here, I'm going to go ahead and tell you what a direct relationship is. So a direct relationship is when one thing goes up, the other goes up. Indirect means if one goes up, the other goes down. And I know the format on this is funky. Don't let I'm not worried about the format. I'll figure that out. So basically in this experiment, if the temperature goes up, does the bounce height go up? So if when the temperature goes up, the bounce height goes up, that's a direct relationship. If when the temperature goes up, the bounce height goes down, that's an indirect relationship. And then what are some sources of error in your experiment? So that's easy for me because I had trouble I'm not a tech person, so I had trouble like dragging and dropping those spheres, and then they would hit the sphere below, or I wouldn't get them exactly at 70 centimeter height to begin with. So any kind of source of error in your experiment you need to account for. That's what a good scientist would do. All right, hopefully that helps you guys.